In JDL, there was the explanation of structures of Cu4I4 PR3 by 4. Sir, in that explanation, they didn't. They mentioned that there are the tetrahedral structures, and at the four corners, the four copper atoms are there. Sir, then what is the central atom in that compound?
Which compound?
Cu4I4 PR3 by 4.
This.
Yes, sir.
The copper is the central atom.
Sir, but in that they told JDL, told that it is a tetrahedral shape and the four copper atoms are at the means four corners.
Yes, it is a multinuclear system. You don't have to worry about it because you don't have multinuclear system in your syllabus.
Okay, sir.
Each,
Sir,
each, cop-
and
each copper is bonded to two copper atoms, an iodide and a PR. So it's a multinuclear system. That is why copper is having tetrahedral, but each having this common with the two copper atoms. And iodide and PR3 are the other two atoms.
yes. Sir, and when CuSO4 is added in water, then which complex ion is formed? That CuH2O by 6 2 plus or CuH2O by 4 2 plus?
CuH2O6 SO4.
Sir, and in the means in the extraction of silver, when the silver is precipitated, why do we again do the electro refining? We get the precipitate, then we should means take the precipitate and wash it with water. Can't we get pure?
Yes, but that is 98 to 99% pure silver. If you want a higher purity silver, then you do the further purification by electrolytic purification.
Sir, okay. Then can we use the extra means the process we use for the CuFeS2 over extraction of copper? Can the same be used for Cu5 FeS4 that peacock over you told?
Can be used because after all the same concept.
And also more copper atoms we can get.
Yes, but the question is the abundance. Whether you have CuFeS2 is more abundant or Cu5FeS4 is more abundant.
CuFeS2. Sir, one question was there in NCRT that FeSO4 solution when mixed with NH4 by 2 SO4 solution in 1:1 molar ratio, it gives the taste of Fe2 plus ion. But CuSO4 mixed with aqueous ammonia in 1:4 molar ratio does not give the taste of Cu2 plus ion. Explain why.
Because copper titanium complex is very strong.
Sir,
You
pardon?
can get the extra copper titanium complex which is formed is very stable. If you decompose by sodium hydroxide, then you will get the test for copper ion. Because you have to decompose the complex to get a free ion. Like when I boil with sodium hydroxide, I get copper hydroxide. Then I dissolve it in HCl and add ammonia, give blue color. I add potassium ferrocyanide, chocolate bound precipitate. So all these tests
Sir,
can be done.
I am not getting means when we say that for a particular metal this test is to test this M2 plus or some when we say that this is the test for testing this radical means if we do some reaction then there is some color change, so even we can have some prediction that if we get this color with this then Fe3 plus or Fe2 plus ions are present. Why the particular test?
Like if you add potassium ferrocyanide, and if you get a blue color, that means ferric is present. If you add potassium ferricyanide, and if you get a blue color, then the ferrous ion is present.
If there is
Ferrocyanide with ferric will give blue color. Ferricyanide with ferrous will give blue color.
blue.
One is called Prussian blue, that is ferrocyanide with ferric.
Ferrocyanide.
So you can see that ferrocyanide iron in 2 In ferricyanide, iron is in plus 3. So plus 3 will react with plus 2 to give you blue solution, whereas ferrocyanide with ferric will give you blue solution. One is called Prussian blue, another is called Tanquist
Excuse me, sir.
blue.
So in the reaction of AgNO3 plus NaX gives AgX precipitate.
Yes.
Except AgF. Why? We get precipitate of all the three, but not of F.
Because F is so electronegative that it forms an ionic compound. An ionic compound is soluble in polar solvent like water. As you go from fluoride to chloride to bromide to iodide, the size of the anion increases, polarizability increases, and silver ion has a good polarizing power, so it turns into covalent compound. So the solubility decreases. Greater the covalency, lower is the solubility in a polar solvent. Iodide is the most polarizable, so silver iodide is most covalent, so it is least soluble in water.
Yes.
Have we done tin?
No, sir.
Tin dioxide is the principal ore of tin, and which is known as cassiterite. It includes many impurities like CuFeS2, FeS2, sulfur, arsenic, and paramagnetic impurity called wolfram. And wolfram it is called ferrous tungstate and manganese tungstate. Ferrous is in 2, manganese is in 2 plus oxidation state. And iron in 2 plus is D6.
Yes, sir.
It is high spin. Because oxygen is a weak field ligand, so you will have 4 unpaired electrons.
Yes.
Manganese 2 is D5, which will have 5 unpaired electrons. So that is why they are paramagnetic. Tin dioxide is covalent oxide. When you heat it in air, first you do the gravity separation, wash it with water, the light particles will flow on the top. Tin being heavy, it will sink at the bottom. Then you do the magnetic separation. Tin dioxide is diamagnetic, whereas wolfram is paramagnetic. So if I put a magnet, wolfram will be attracted and tin dioxide will not be attracted.
Yes.
Then I do the roasting, where sulfur will go out in the form of sulfur dioxide. You can double the reaction, you can write as 4 arsenic plus 3 oxygen, it's 2As2O. If you don't want the fractional, you can just multiply by 2, so you get the whole number.
Yes.
It also volatilizes. CuFeS4, S2 gets changed to copper sulfate, ferrous sulfate, and they become soluble in water. So you get a copper sulfate, aqueous solution of copper sulfate, aqueous solution of ferrous sulfate, whereas tin dioxide is insoluble in water. So you will have tin dioxide free from iron and copper and manganese and tungsten. The wolfram is also called tungsten. Tungsten is also known as wolfram. Yes, but this wolfram, which is associated with cassiterite as an impurity, is iron 2 tungstate and manganese 2 tungstate. Ferrous tungstate and manganese tungstate.
Yes.
You are free from impurities. Then tin dioxide is reduced with carbon around 1200 to 1300 degrees Celsius to give you tin and carbon monoxide. So it's a carbon reduction. Carbon is a useful reducing agent at a high temperature.
Yes.
So carbon reduces tin dioxide to metallic tin. Carbon monoxide goes out in the form of gas. How do you know it's a carbon monoxide and not carbon dioxide? How do you know that it is the gas which is coming out is carbon monoxide and not carbon dioxide? The same reaction if I write. How do we distinguish these two reactions?
When temperature is high, carbon combines with oxygen to form carbon monoxide.
Carbon binds with oxygen to form carbon dioxide also. Simple reaction is carbon monoxide bonds with a blue flame. Carbon dioxide is absorbed in alkali, not carbon monoxide. So if I pass the gas through KOH, carbon dioxide will be absorbed.
Yes.
And the gas which will come out is carbon monoxide. But the easiest, the simplest distinction test is burn the gas and see whether it burns with a blue flame or not. If it burns with a blue flame, it is carbon monoxide.
Yes.
Two gases burns with a blue flame. Carbon monoxide and H2S, these are the two gases which burns with a blue flame. Now you purify electrolytically. So take impure tin as cathode, anode, pure tin as cathode, and stannous sulfate, sulfuric acid, and H2SiF6, hexafluorosilicic acid, as electrolyte. Okay?
Yes. Yes.
So impure tin will get oxidized. Impure tin will get oxidized to tin 2 plus, and stannous ions will get reduced to metallic tin. So at the anode, tin goes to tin 2 plus, releases 2 electrons, and stannous ion from the electrolyte precipitate deposits at the cathode. I told you that is the basis of electrolytic purification. Impure metal as anode, pure metal as cathode,
Yes.
and the solution of a salt along with free acid as electrolyte. Two well-characterized allotropes are known. The third one, there is a rhombic tin which is not well characterized. But these two allotropes have been well characterized. This is a crystalline, most stable. So what you see in the rooftop, tin sheet on the rooftop or the fencing, tin fencing, is bitter tin or white tin which is crystalline. And bitter tin is the most stable variety of tin when you cool it to less than 14 degrees Celsius for a long period. it changes to gray tin or alpha tin. And it is powder. So alpha tin or gray tin is formed from beta tin, which is crystalline. When it is beta tin is cooled at less than minus 14 degree for a long period, it slowly converts into gray tin. As a result, the crystalline variety changes to powder form because this is a powder.
Excuse me, sir. So, what is the reason for that stability of beta T?
Beta tin is the most stable variety at room temperature. And that is why in our country we get roof tin roofing, or for fencing we use tin sheet because the temperature is not very cold. You can't use tin roofing in Kashmir because there in winter it will change to grey tin and the sheet will crumble into powder. And that is known as crumbling of tin plague or tin pest. That is when the crystalline tin changes into powder form. It is called tin plague or tin pest.
Excuse me, sir. Sir, in that beta tin, we would have a very good, very aligned arrangement of the atoms. So instead, we would have to supply energy to convert it into powder form. Here, we are cooling the temperature. Sir, how does
No,
it get?
you don't have to supply the energy to cooling point. It depends upon the allotropic structure. One crystallizes in the crystalline form, another crystallizes in amorphous form. So you don't have to, does not mean that to change from crystalline to amorphous, you have to provide heat, not necessarily. Here, it is a slow change because the most stable variety is changing into less stable variety. But that happens only when you cool it at a very low temperature. This undergoes a structural change, and as a result, you get a powder.
Yes.
Beta tin has a density 7.32 grams per centimeter cube, whereas alpha tin has a density 5.74 grams per centimeter cube. So you can see, for a given mass, if the density decreases, what happens with the volume? When for a given mass, if a density decreases, what happens to the volume? That is why it changes to powder. Yes. That is the reason why it changes to powder. For a given mass, the density is decreasing, volume is increasing. Tin shows two different oxidation states, +2 and +4. +4 is the most stable oxidation state of tin. That means tin in +2 is called stannous ion, and tin in +4 is called stannic ion. So stannous ion will be a reducing agent because the higher oxidation state is more stable. So the lower oxidation state will behave as a reducing agent. When you burn in oxygen, you get tin dioxide, which is a white powder. It is amphoteric in nature. That means it dissolves in acid as well as in alkali. So when I take tin dioxide, heat it with concentrated sulfuric acid, I get stannic sulfate. If I dissolve in sodium hydroxide, I get sodium stannate. So you can see that tin dioxide is an amphoteric oxide. It dissolves both in acid as well as in alkali. Stannic ion If I pass H2S, I get stannic sulfide, which is yellow, which is called mosaic gold. Stannous oxalate. When you heat, you get stannous oxide, carbon monoxide, and carbon dioxide. And this is a gray to black powder. Tin dioxide was white,
Yes.
whereas tin monoxide is gray to black powder. If you heat it further, in presence of oxygen, it will change to dioxide. Because tin in class 4 is more stable. Another method of preparing tin monoxide is take stannous chloride. To stannous chloride solution, you add sodium hydroxide dropwise, not in excess. You will get a precipitate of stannous hydroxide. Stannous hydroxide will dissolve in excess sodium hydroxide. So I don't want to add sodium hydroxide in excess. I just add dropwise so that the clear solution of stannous chloride, when it gives a precipitate, I stop addition sodium hydroxide. Then I filter, and if I heat it in carbon dioxide atmosphere, when you heat in presence of carbon dioxide atmosphere, carbon dioxide being heavy than oxygen, is a heavier gas than oxygen, so it will displace the oxygen and you will get tin monoxide and steam will go out in the, water will go out in the form of steam. And this is how you can prepare stannous monoxide. Not in presence of oxygen, in absence of oxygen in carbon dioxide atmosphere, when I heat it, I will get tin monoxide.
Yes.
Tin monoxide is also amphoteric.
Excuse me, sir. Sir, you have given here like the density of white tin and grey tin is like decreasing there. So here when the crystal is convert to powder, their volume is not changing. Only surface area is changing. So how do we concern this density change?
Why there should be a change in density if the volume does not increase? A crystal always requires a less volume than the powder. Crystalline form is always more dense than the powder form. Because that is why the volume increases. It is not this, that means it is, if the surface area is increasing, that means it requires a larger volume to cover than the crystal would require.
Sir, if I am considering an example of an ice, then ice has the same density of melt. If we melt one ice, so the water form has same volume as the ice have.
No, water has the highest density at 4 degrees, not at 0. In ice you have a cavity. And when you melt it, the cavity disappears and becomes denser. Tin monoxide is also an amphoteric oxide. It dissolves in HCl to form stannous chloride plus water. It dissolves in sodium hydroxide to form sodium stannite, which is a reducing agent. Because any compound of tin in plus 2 is a reducing agent. Whether it's stannous chloride, stannous sulfide, or stannite, all are reducing in nature. Because tin plus 4 is the more stable oxidation. When you have excess tin and dissolve tin in HCl, but not completely. There should be some amount of tin left in the solution. That means below the solution, there should be some amount of crystalline tin present. Then we will have tin dissolve. When you dissolve in HCl, you get stannous chloride and hydrogen. Now if you dissolve all the tin, then what will happen? The aerial oxidation will convert into stannic chloride. But when tin is in excess, even if some amount of stannic chloride is formed, it will bring back to stannous chloride. So as long as you have undissolved tin present in the solution, there will be no scope for formation of stannic chloride. Because even if it is formed, it will bring back to its lower oxidation state. Stannous chloride is a white solid. There is another method of preparing stannous chloride is take tin and mercury chloride. 1:1. And distill it, you get tin, stannous chloride, and mercury is precipitated. Mercury is insoluble in water, stannous chloride is soluble in water. But I will not dissolve stannous chloride in water, I will dissolve in dilute acid. Why? Because stannous chloride, in absence of water, acid, will undergo hydrolysis. Stannous chloride will undergo hydrolysis to form SnOHCl, which is a white precipitate. But if I add HCl to stannous chloride solution, will the hydrolysis will take place? Due to common ion effect, the hydrolysis will be neglected. The reaction will not take place because stannous chloride on hydrolysis gives me HCl. Now if my solution already contains HCl, the liberation of HCl will be prevented, so the hydrolysis will not be there. That is why stannous chloride solution requires acid. You can dissolve stannous chloride in water in presence of an acid so that it does not hydrolyze to give you a white precipitate. Stannous chloride is a reducing agent. It will reduce ferric to ferrous. And how do I know that it reduces ferric to ferrous? Because ferric chloride is yellow in color, whereas ferrous chloride is colorless. Almost colorless. It is so pale blue color that you can't see. So the color, the yellow color will vanish. And stannic chloride, so this to this is a 2 electron change. Tin 2 plus going to tin 4 plus 2 electron change. Ferric to ferrous is a 1 electron change. So I require 2 moles of ferric per mole of stannous chloride to give 2 moles of ferrous, 1 mole of stannic chloride.
Sir, in the first reaction Sn plus HCl, why is that oxygen required from air, or why don't the Sn directly form SnCl4 Sn plus HCl?
HCl is not an oxidizing agent. I will give you how to prepare SnCl4. HCl is not an oxidizing agent. Chlorine is an oxidizing agent. So chlorine will oxidize tin to tin 4 plus, but not HCl.
Yes.
sulfuric acid, nitric acid, they are oxidizing acid. Hot concentrated sulfuric acid is an oxidizing acid, not dilute sulfuric acid. Similarly, HCl is not an oxidizing acid. It's an acid. That's all. Nothing else. So it will not oxidize stannous to stannous.
No, so why don't directly form SnCl4 directly? It combine with 4Cl and SnCl4.
Then you require an oxidizing agent.
Yes.
It requires an oxidizing agent to oxidize stannous to stannous. That is why when you heat tin with a oxidizing agent like chlorine, you will not get stannous chloride. You will always get stannic chloride. Because
Yes.
chlorine will not stop tin as +2. It will straight away take it to +4. Yes.
So in second reaction, you said SnCl2 should not be dissolved in H2O. But when we will dissolve in acid, the factors for Hg will also contribute, na? Its reactions also. Mercury. When that SnCl2 is dissolved in some acid, you said due to common ion it will not hydrolyze. But at the same time, Hg will also will have its reactions with acid, na? Hg.
No. Mercury. There is no mercury. I am saying stannous chloride should not be dissolved in pure water. It should be dissolved in acidified water. There is no question of mercury. Where is the mercury comes into picture? I am talking about the hydrolysis of stannous chloride. Why are you confused with mercury?
Yes.
Stannous ion, when you react with mercury, when you add, say, mercury chloride solution, if I add stannous chloride to mercury chloride solution, drop one. I add stannous chloride to mercury chloride, drop one. I get mercurous chloride, which is white, which is known as calomel. When I add excess of stannous chloride, I get stannic chloride and mercury. So if I add stannous chloride to mercury chloride, slowly, dropwise, then at first the mercury +2 will reduce to mercury +1. When I add excess of stannous chloride, it will reduce further to mercury.
Yes.
Stannic chloride, okay, stannous chloride plus gold chloride. In presence of water, it will form metallic gold and H2SNO3. This precipitates as a colloid. This precipitates as colloid. So if I add stannous chloride to gold chloride solution, auric chloride, the gold will be precipitated, reduced to metallic gold. Its the nature of the gold will be in the colloidal form. Do you understand what is a colloid? Yes. So it will precipitate as a colloid, and stannous chloride will get oxidized to stannic chloride, which will undergo hydrolysis to form stannic acid. Stannous chloride reduces gold chloride to gold. Stannous chloride gets oxidized to stannic chloride, and this undergoes hydrolysis to form stannic acid. So stannic chloride will hydrolyze even in dilute acid to form stannic acid in the colloidal form. And this mixture, the mixture is known as purple of cassius, which is used for gold coloring of glass, potteries. You will get so gold-plated glass, gold-plated cups.
Yes, sir.
This is the source of gold coloring, the purple of cassius. What?
Sir, in that reaction of tin and AgCl2, in which we get calomel, why do we need to add it dropwise?
Because if I add excess of stannous chloride, it will go to market. Can you write now?
Yes, sir.
To acidified solution of stannous chloride, if I pass H2S gas, I get a brown precipitate of stannous sulfide. Whereas stannic sulfide was yellow. So looking at the color, you can distinguish whether it's a stannous sulfide or stannic sulfide. One is a bright yellow color, golden yellow color, that is stannic sulfide, and one which is brown is stannous sulfide.
So why does it require an acidified solution?
Why does SnCl2 require acidified solution in the last reaction?
Just few minutes back I discussed that part. That SnCl2 in absence of acid will give a white precipitate of SnOHCl. Stannic chloride forms a variety of hydrates. One of the hydrate is known as butter of tea. This finds application as a mordant. What is mordant? Mordant is a chemical agent which helps the dye to be fixed onto the cloth. So if I want to apply a dye onto the cloth, I don't apply dye directly onto the cloth. First I put the cloth into the mordant, then I apply dye. Mordant acts as an intermediate agent to fix the dye onto the cloth. Stannic chloride, I told you stannous chloride is a white solid, but stannic chloride is a colorless